early, especially after, the opening social last night. Some of us were up a little late. So I appreciate you being here. It means a lot. Excited today to start our discussion with our distinguished panelists. I have everyone's name, and look, you guys are so orderly. You sat right underneath your picture. I'm so proud of you. So we'll start with introductions. We'll go through a series of questions that I'm going to moderate on this panel. And quickly, I'm going to open it up. So if you guys have any questions, you can ask our panelists. Then we'll go into the discussion about our demo and what we're planning to do, and what kind of payloads we're looking for. So we can make a perfect match for that. And then afterwards, we can do some more socializing. So yeah, if you could hold your questions, I will get to a Q&A session right after our panel. So thank you very much, and enjoy the show. And please raise your hands if you can't hear us. Can everybody at the back hear me okay? All right, excellent. All right, good morning. So I'm Negar Feher. I am the CEO of Orbital Outpost X, and I'm going to let each of our panelists spend a couple of minutes introducing themselves and what they do and their backgrounds, and then we'll roll into the questions. So, Aaron?
Thanks, Negar. Thanks, everyone, for joining us this morning. I'm Aaron Mitchell, Director of Product at Impulse Space. So Impulse is a company founded on the idea of revolutionizing in-space transportation. Impulse was founded by our CEO, Tom Mueller, who was employee number 1 at SpaceX, and you might know him as an expert in propulsion, the founder or the creator of the Merlin engine. So Tom, after working at SpaceX for over 18 years, decided that he viewed launch as a solved problem, and now he's ready to look at solving the in-space portion of the transportation problem for the space industry. So Impulse has a line of products. We have 2 different sizes of vehicles, orbital transfer vehicles, or OTVs. One is a Espa Grande class vehicle that we launched last year for the first time on Transporter 9. Had a successful first flight, demonstrating deploying payloads and maneuvering in orbit. We have another flight coming up this year, and more coming after that. That vehicle is called Mira, and we also have a much larger vehicle that you could still consider an OTV, but is in some ways more of a high-energy kick stage or a third stage for a rocket, and that will be launching in 2026. We call it Helios. It's designed to deliver 4 metric tons of payload from LEO directly to GEO. So that's Impulse Space, and looking forward to the panel.
Thank you.
I'm Rahul. I'm with Arkisys. At Arkisys, we are developing a robotic platform for hosted payloads in low Earth orbit. So think of it kind of like a cross between an Airbnb and AWS in orbit. So you can rent a slot, we attach your payload, we provide it power and data, you run your mission, and then we handle everything else, white glove service. And then once your mission is done, we swap you robotically for a new payload in orbit. So our first upcoming launch will be a smaller version of our full port module that we call the Cutter, an OTV class spacecraft, about 300 kilograms, and we can host 6 to 8 payloads. One of the things that we have integrated into our design is modular interfaces. We need interfaces so that we can swap these payloads robotically in orbit. So that's why we are very interested in what OOX is doing.
Thank you.
Hi, I'm Mike Johnson. I'm the CTO of SEOPS. SEOPS is a company that, well, I guess we could probably best describe as a mission consolidator. We fly CubeSats on various launch vehicles, in particular the SpaceX Falcon 9. We started deploying CubeSats off the International Space Station with our slingshot system, using the Cygnus cargo vehicle, basically take us from the space station up to higher altitude and deploy satellites from there. I was also a co-founder of Nanorox, and back in around the 2012 timeframe, we started deploying CubeSats off the International Space Station. It was a very exciting time from 2012 to 2016 era. We were able to really start delivering CubeSats and small satellites to space via the International Space Station. And it's just fantastic to see what has happened to all of this over the years. And it's Negar reminded me that I'm probably the oldest one on the panel, but I don't feel like it. Every time I come to a small sat, it's very exciting and invigorating to see all the new companies and I'm not as familiar with Arkisys, but it sounds like fantastic idea. That's going to be great. And of course, Aaron and I know each other from other places, but I think we'll have fun today. Thank you for coming today.
Thank you, Mike. And no, I meant my comments previously complimentary.
I'm beginning to realize.
And based on that and your history of, being at the forefront of, the small sat movement, integrating so many payloads on orbit, can you share some of the mishaps that you've seen on, integration, launch, that could have been caused by payload integration issues or others due to software and related interfaces, and how those went? Because I'm sure you have a lot of juicy stories.
Well, yeah, there were some fun times. Very fun times that continue. Fun times still happen. It's very curious, but one of my, I guess one of my favorite stories I like to tell people starting out in the CubeSat world. We had just gotten in a CubeSat to do a test fit into one of our deployers, and the team was there. They were very happy, very excited, and that's an exciting time. And we had about maybe 4 hours before we had to actually turn over the payload. So this is the first time we were doing a physical fit check. And we put the CubeSat in. It was a 3U. And I will never forget the sound of that fit check. It was like, and the poor kids were pushing it in to the deployer. And I said, wait, hold on. Let's back up. Can you pull that out for just a moment? Let's try this again. Maybe it's just a little off filter. And the lead fellow, he says to me, he looks me straight in the eye, and he says, don't worry, it'll work in space. We probably took it out. I have a machinist. Let's take this down to the machine shop and look this over. No, that's not possible. It's very possible. Let's do it now. Okay. And sure enough, an hour later he comes back, smooth fit, and it was a successful flight. It will not work in space if it doesn't work on the ground. So it's very important that everything must work on the ground. And but other than that, I would say that I guess seriously looking at different things that are important to take care of ahead of time. Anything that you have with your satellite that involves some form of bureaucracy, very important to take care of that as soon and as fast as you can, in particular radio licenses. So in the Natarax days, and actually sometime in the early SEOPS days, when we would fly things up to the International Space Station, and they'd be on orbit for maybe a couple of months, sometimes shorter periods, but we were able to launch these satellites without radio licenses. But sometimes they get stranded in space and we wouldn't be able to get these licenses in time. Very important. Well, of course, nowadays, you're launching on real launch vehicle rockets, like SpaceX, for example, Falcon 9. You can't even load your satellite onto the vehicle without those licenses being in place. And there's very subtle licenses too, and it's a function of the home country of the satellite too. It's very important that we pay attention to that. So a lot of the European nations only require like ITU registration for your radio license. So that's very easy to take care of that. But in the States, they require FCC licensing. And then if you have a camera of any sort, it's the smallest of cameras, like maybe a docking camera or something like this, you have to go through NOAA, the weather administration. make sure that you get a license for that kind of stuff. These are very important, and it's like, it's not really a technical problem. Technical side, other than like vibration testing, there's some really funny stories there, but it's the licensing. Just make sure you follow that down.
Thank you. So Rahul, let me ask you a question. In your line of business with modular ports, how are you ensuring that everyone can, in the market who wants to integrate onboard your ports can easily integrate? And what advantages does any interface provide to, having an interface to connect your payload to your port versus, direct integration?
Yeah, it's a good question. So I mean, in our business model, we bring payloads that have an interface that can connect to our platform. So our platform is built with modular interfaces that can transfer power and data and do mechanical interconnect. And they can do this robotically, so without a human in the loop. So you do this in orbit with a robotic arm, transferring payload and interface. So before that even happens on the ground, we partner with different interface companies to provide our customer interface. We mail the interface to them. They integrate that to their design. And before they even send us their payload, we also send them something called the applique. It's a device we developed as a patent pending process for remote integration. So the applique is a universal data protocol adapter. It sits on our spacecraft between the interface and our flight computers so that we can convert any data protocol they have into something we can read. But we also send this to them on the ground so they can do hardware-in-the-loop testing with our platform over a secure VPN before the hardware leaves our facility. So this streamlines the process. And when they get the hardware to us, it's ready to integrate, send it all up, and we can operate their payload in orbit. So the use of interfaces to do this is key. But what makes interfaces better for the customer than just integrating directly into a spacecraft is that after they're done their mission, end of mission does not mean end of life. We can transfer their payload to another spacecraft that has the correct interface, and they can go on a second mission with the same hardware. Don't need to send up a new set of hardware. So we can modularly adapt payloads after the fact in orbit. And then on the ground, any interface that we're going to bring onto our system, we fully validate, verify that it will work on the ground, and that it will be able to disconnect, reconnect multiple times, because we want this to last in orbit.
And do you ever have a situation where you need to swap these payloads on the ground before you launch? Has that ever happened?
So I mean, it makes it easier. We haven't. Our first launch will be end of next year, so we haven't yet launched payloads. But when we do, it does make it easier in our ConOps to, if a payload hasn't delivered on time, we can swap it in a backup payload without having to do major reintegration of the spacecraft.
Nice. So thank you. Aaron, just a question for you. What hardware and software products do you wish you had at your disposal to assist with onboarding new customers and payloads to deploy them in their desired orbit or host them and operate them on orbit? What would you like to do?
Yeah, so right now we deploy and host various payloads on our OTVs, and every time we onboard a new customer, it's essentially a process of establishing what kind of standards we're going to use, both for data, power, and mechanical interfaces. We haven't, we essentially are creating those standards as we need to, and I would say the biggest issue is not the lack of any one specific product, but just the lack of a industry standard across the board, right? There's, if you have a lot of European customers, for instance, they will often say, oh yeah, we definitely need SpaceWire, and then more American customers are fine with Ethernet, data connections. Some folks need regulated power, some folks are fine with unregulated 28 volt. There's, in terms of mechanical interfaces, you think there's kind of these standard 8-inch, 15-inch, 24-inch, but then if you zoom in on these drawings, a lot of times you'll find 15 inches, not a 15-inch, right? There's, especially if the drawing was made in metric, or it really matters. That's how you get the screeching CubeSats, right? That's usually a millimeter off.
Just a few thousand.
Yeah, well, when standard ends up getting adopted, but you can kind of think of like other industries like electronics where there isn't really a question about what interface you're going to use if you want your electronic, your new gadget to plug into something, right? You're going to use USB. We would love it for the industry to get to that point. I think the space industry is a long ways away from it, but it's great to see companies like yours trying to push towards that future.
Thank you. I appreciate that. So, Mike, going back to you, we talked about like CubeSat standardization and standardization in general, how it's made, space more modular, and it's made it easier to integrate things, lowering the cost and the barriers to getting things to space, which is basically increase and democratize space on this, CubeSat realm. Now, looking at a similar inflection point as we're looking at small sat and larger satellites that we're launching now, thanks to lower cost of access to space, what type of standardization do you think we need to employ in that realm, in that size satellite class, in order to get the similar kind of result? Because I'm not seeing that yet in the small sat realm beyond CubeSat. So, just would like to hear your insight and the other panelists on that. Like, what do you think needs to happen?
Well, one trend I've been seeing over the years is that as the cost of launch is increasing, the satellites are filling that vacuum. They're getting larger. So when we first started doing CubeSat launches, kind of the 3U was sort of the standard. And over the years now, it's really advanced to the 6U and 12U territory, mainly 6U. But Starship is on the horizon. Starship comes along, my prediction is launch costs are going to drop one more, at least, maybe close to an order of magnitude. So say we're at 6,000 now, maybe. I'm kind of predicting maybe $1,000 a kilo. I think when that happens, keep the standard satellite, it'll morph into something like maybe a 50-kilo satellite, which kind of puts us into utilization of, say, like an 8-inch separate. And one thing that's kind of been ignored that I've seen throughout my career in satellite launching and deployment is everybody's worried about either the launch vehicle or the satellite, and they're not worried about the interface, the separating, the connectors, or for example, the equipment that your company is working on right now in Arkisys too, and then I think Aaron and I are kind of victims of the lack of standardization. And honestly, if the developers really focus on how to make that happen, but where the deficit has been though is in the industry has been not really developing the standard. I mean, we have light bands that come in standard sizes, but even on the light band, connectors may vary. There's also various separation mechanisms in that class of satellite that really are not standardized. Even SpaceX, gone to this 4-point mounting system. They talk about it in their interface control document, and people are looking at using 4-point systems. But I think Aaron, you can attest to this: the 4-point systems are not standard. They are absolutely customized to the satellite, and it's not something that you can't just go buy this thing and bolt it onto your satellite and run. And with these larger satellites, for the ability to launch larger satellites, so say if the new standard goes to say like a 50-kilo satellite, it also means that the larger satellites are going to be well beyond, say 300 kilos, which is kind of like a big microsat that you would fly on a SpaceX mission. And I think, Aaron, you guys are probably looking into the 700-kilo sector, maybe somewhere in there. And we're going to need standardized interfaces for that. We're not here yet, but we're working on this at our company, and I'm certain that you're working on this because can't have robotic interfaces without some other kind of standardization. And then, of course, actually, what you're doing is going down the right path, absolutely. Because, and this is something too you shouldn't have to worry about. If you're building a satellite, you got other problems. But also the volumetrics of it too. We see things with antennas and all sorts of appendages hanging off. People need to come back and kind of look very closely at what you're doing, especially if you're going to start making constellations of these things. So yeah, standardization helps.
Yeah, and just following up on that for everybody here on the panel, to help solve some of these problems that we've highlighted today, do you think the commercial sector is better suited to address these, or the government, in order to implement more modularity and get to a point where a lot of these things are standardized? And is standardization the solution, you think, the direction we need to go to? Or do you think that there is another solution that would better solve some of these problems that we've addressed?
I can take that one as well. I think standardization is going to happen, but organically rather than, I don't think the government should enforce this. I don't think they will, but they should not.
Yeah.
I think it's up to industry to figure that out. But I don't think it'll happen for the next few years. I think there's quite a few interface companies that are developing interfaces. They're going to be testing them in orbit, and it'll be feedback from their customers that drive what portions of interface are good, what needs to be changed. And I expect to see at least some convergent design leads to the types of capabilities interfaces will provide. And then at that point, it'll be up to the customers to decide what works best.
I think what I was going to add, I was thinking about this over the weekend, and a lot of the industries, like electrical industries, have standards committees and things like IEEE, for example, electrical side, ASME, and mechanical side. You don't really see that in space right now. But at least that I'm aware of, maybe somebody started something.
I mean, there is Converse that is working on standards for space, at least. They are doing interface work, not on the interface as a whole, but portions of how the interface work. But I think, there does need to be some work on the full interface.
That may help. It's not a government thing. It's all commercial community, or that industry getting together, creating the standards. So maybe that's what's.
Yeah, I think I agree. I think the government will follow whichever standard the majority of the industry adopts in the long run, because that will better serve them too.
Like mill standards. You see this fascinating.
Okay, so I want to open it up to the public, to the audience, to see if anybody had any questions you wanted to ask our panelists before we go in. Yes, Martin, please.
I'm Martin Meerman. I've been doing small sat since the 1980s at Surrey Satellites initially, and then Maxar. I've seen many attempts at people developing standard things, a standard bus, a standard whatever, and I've yet to see a standard that actually works. And a number of companies that have spent large sums of money on developing a standard bus, and then any mission that came through never fitted the standard bus.
That's right.
Because the standard bus was developed for a particular mission in mind, typically, but every orbit is different. And one has got high drag, the next has got high atomic oxygen, the next doesn't have any of that, but it's got lots of radiation to cope with. The next one needs to be very precisely kept in orbit at a particular position. The next one has to be very stable. And these kind of things are often completely opposing each other. Right? You want lots of power, you can have turning solar panel. That's not going to give you a lot of stability. If you want both, you can do that. You build worldview satellites, they do both. They're not cheap satellites, right? They get very expensive. So any interface that in the past people have thought about unless it's a super basic one that, when you plug in the wall. But even then, you come from another country, you need a conversion plug. So otherwise it doesn't work. And I can tell you that whatever standard interface you develop, like the first guy through the door that says, oh, I want to use that interface, I need the following, that you can say, dang, right? You want what ingress currents, you want what radiation hardness, you want what material spec, you want what data rates to go through there, you need what impedance. And if you've got a mounting interface that you can robotically put in and out, and also you can put it in on the ground and launch it, and it will withstand launch vibration, yet you can robotically pop it out in space, that's impressive. But the first guy that's going to come through the door says, yeah, I want to use that, here's my payload, you can look at that and say, how you can avoid that?
I mean, I think that's a really good point, Martin, and I know it comes from, personal experience dealing with that. And I know we've had these conversations, but I think that there isn't going to be yield in one standard at the end of the day. The same way with everything we have on Earth, like you just mentioned, the power, the power centers in the U.S. and Europe are the same. So I think just having a set of standards that you can develop to, that you can explain to your customer base as they're developing the payloads, will help expedite the process and, help people build in a more modular fashion. And, going back to your example with the bus, if you build your bus in a modular fashion where you have different modules, where you can swap out the high power module for a lower one, etc., that's when we'll eventually get to that point. But it is true, there are a lot of opposing requirements, and because of that, I don't see that we will end up at the end of the day with one standard, but there will be numerous ones for various applications.
Like, are you going to have an amount of thermal energy going forward back through that interface, and you can specify that?
Yes.
How much you're going to allow or not allow? Any chafing, how precise you need to be aligned. The range of things that once you actually turn into an interface spec with somebody, and you end up with an interface document this thick. That happens all the time.
But at least if you have one that's standardized to that level, it'll alleviate having to recreate that wheel every single payload.
Sure.
You
But there's always the moment, like, right, that didn't fit.
Yeah.
That requirement.
Well, also too, I think, like with the CubeSat standard, I'm the first to admit it's not standard. Almost every CubeSat is a customized thing that comes in. But that, the rail standard and the enclosure standard, the ISIS standard, for example.
It's the only thing that matters in the CubeSat.
Yeah.
There's only one thing that a CubeSat is. That is a steel box that only
circuit
operates.
boards, right? Yeah.
But because you go to a project manager and you say, your $200 million mission, I can get you another 50,000 if you launch some student's CubeSat. And the project manager can look at that, that thing can break, damage my satellite, and do $200 million worth of damage. I can get rid of that risk by just foregoing 50,000.
Yeah.
That is such an easy thing. So now you're going to say, okay, we're going to put it in a steel box. That steel box only opens once you're safely out of the way. That's the only thing that matters. So basically, anybody who says CubeSat says, I don't know what I'm doing, I'm too much of a risk, I'm going to sit inside a box, I can't have an antenna sticking out, I can't have a baffle sticking out, I can't have anything sticking out.
I would
only
say
thing that matters.
Yeah, I've seen some interesting CubeSats, so that once, this is where I was going to go with this. You have your launch configuration, which of course is completely different from your deployed operational configuration. So the CubeSats do. I've seen some very clever things where things expand, they separate, they create very large antennas, for example.
Half of them don't work, by the way, but
yeah,
a lot of it that has to do with exactly that. They have to be too clever for their own good. And so the only thing that the CubeSat standard is a steel box that is safe.
Yeah.
You take that safety out, okay, now you can launch.
But you're right, and seeing this advancement on larger satellites is how do we get to something that, for example, if you could buy a standard set of solar panels, it'd be very useful for the community. And I think right now too, the launch costs are too expensive at this moment, even though they have come down quite a bit. It's just too expensive to have this, completely standardized system. But as Negar was saying, starting at lower level, trying to get the connectors, trying to get the some of the mechanical things in the standard, kind of like a toolkit, if you will. Try to use the tools. That's a big problem. This is a very big problem, and it's too expensive to not customize yet. But hopefully soon that will start to disappear.
Thank you. So we have time for one more question before we go to the next segment, please.
I guess the big question is when you're looking at interfaces and standardization, I think there's like the big move you saw from MOSA within the DoD that's trying to translate into a lot of like space application. You see via like tranching the SDA. It's really interesting to see a large amount of commercial companies trying to push kind of this physical hardware standardization. So I'm really curious, especially like Arkisys and you guys, how exactly do you see a commercial company being kind of the natural standard the industry leads to versus some other kind of like non-productized version of a standard that would still like simplify the workflow for payload satellite integration without necessarily needing to abide by a certain form factor. If you look historically, it seems like that's kind of the approach. So I'm curious how you guys see, especially like CEO systems engineering difference and how that problem is actually.
Yeah, I guess so from my end, so Arkisys, we don't build interfaces, we go buy them.
Yeah.
So we talk with multiple vendors, and we test them all at our facility. So we have a full-scale mock-up of our platform with a robotic arm on board. We're able to manipulate payloads on the ground. And so we do that with every interface that we consider putting on our platform so that we can verify that we can be compliant, we can move payloads of various sizes around, and we give feedback to the interface provider that we think you should alter your design this way to make it more compliant, more easier to attach, more reliable. So in that way, we are driving a bit the standards themselves, or at least the interfaces, but we're also taking input from our customers. We're getting our customers saying, we need to host a 10-kilogram payload in this volume, and here's the center of mass. We need to move it around. So we're taking all that, doing our own analysis, and passing it on to the interface providers. So that's our role in that.
Yeah, and just follow up on that. You mentioned the SDA. I think that they're actually, from the government perspective, playing a critical role here in being the informed buyer that kind of sets some standards to a certain extent, but not in a concrete manner where like a lot of different commercial vendors can't participate in that activity. So let's say with the optical communication standards, right? They were like, we want to see this happen. And for years they watched the commercial industry try to implement this, but because there wasn't a forcing function saying, oh, we need it to hit these standards in order for it to be used by us, there wasn't any agreement within the industry on, one particular standard for optical communication. So I think them stepping in and helping with solving that problem has helped all the people working on that, kind of come together and agree on a standard. It was kind of, initially forced by them, but by them becoming a buyer of that, it helped push that along. And I think similar trends will happen as they launch more and more tranches. And I think it's critical for the commercial industry to be watching that closely and to be responding to every time both the government and the commercial markets are asking for these kind of things to develop the products in that fashion. And all of this, at the end of the day, would enable more modularity that would naturally pull for more